Okay, welcome back everybody. Let's take a look at one additional drug calculation technique, and this is going to be for the infamous dopamine drip. This is the one that seems to foul people up, and I'm not sure why. I guess it's probably because there are a number of steps. So dopamine drips they are provided on a microgram per kilogram per minute scenario. So in this case, the general dopamine drip rate range is 2 micrograms to 20 micrograms per kilogram per minute. So that's you'll remember that once you look at the protocol and you study the drugs a little bit. I'm just going to use 10 to make the numbers work out okay, and they're going to work for us. All right, so there are a few things you need to know about dopamine. So let's take a little step back before we do any calculations, and let's take a look to see if we can make some sense of this mess. All right, so there are a couple things you need to know about dopamine, and dopamine comes in a pre-filled bag for us, but it doesn't always, and the pre-filled bags come in varying concentrations. So when you look at dopamine, your dopamine bag should be in a 400 milligrams in 250 cc. Actually, I'm in a bad habit of using cc's and milliliters interchangeably, and they are, but I'm going to use mLs just for consistency's sake here. So when you look at this, it's important for us to understand that anytime we have a big number, anything other than 1 in the denominator, that presents some challenges for us later down the road. So in your dopamine pre-mixed bag, there are indeed 400 milligrams in 250 cc's, but that's not a really usable or user-friendly number, so we got to do something with that. So we're going to reduce this into its lowest function, and we're going to reduce it so that we know how much, what number of milligrams exist in a 1 milliliter piece of that. So we're gonna divide these 250 into 400, and we're going to end up with 1.6 milligrams per milliliter. Now, as you remember on the previous slide, what I told you was that our dosages, our prescriptions, are in micrograms. They are in millionths of a gram, microgram. So in order for us to, again, do something usable with this, it's going to be important for us to, again, make this conversion so that everything is comparing apples to apples. So we need to do something about this. We need to get rid of milligrams. So we're going to do that with a proportion. So we're going to put milligrams on the bottom, and we're going to say that, in fact, we want to go to micrograms. All right, and for every 1 milligram, there are 1,000 micrograms. So if we do this calculation, what we find is that there are 1,600 micrograms per 1 ml of volume of solution. So when you look at your dopamine, it comes in a 400 milligram dose in 250 cc's of volume of lactated ringers, or D5W, I apologize, D5W. And in fact, what that translates to us to something usable is that there are 1,600 micrograms per milliliter. All right, so we're going to come back to that in a little bit. Let's just start with that, and let's just come back to this and say, all right, we know now that there are 1,600 micrograms per milliliter of solution in a pre-filled dopamine bag. And remember, that pre-filled bag must be exactly 400 milligrams in 250 milliliters. There are other concentrations out there, so please make sure when you restock from the hospital, or you restock from anywhere for that matter, that you confirm it is the 400 milligrams in 250 ml volume. All right, so let's take a look at this now. We're going to say that we have a patient who weighs 176 pounds, and that patient needs to receive 10 micrograms per kilo per minute. So ultimately, what we need to know is how many drops per second does that translate to. So we're going to do the first thing we always do. We're going to convert 176 pounds to something we can use, which is kilograms. We're going to get rid of our pounds here in just a second. All right, and this is going to equal 80 kilograms. All right, so far so good. Next, we're going to take our 80 kilograms. This is the patient's weight. We're going to multiply it by the dose that we want to administer per kilogram. 10 micrograms per kilogram. We'll get rid of our kilos. And we end up with a total dose of 800 micrograms per minute. So we need to administer to this patient 800 micrograms of dopamine every single minute. All right, so now what do? Well, remember that we have this desired over on hand times the volume. So this is going to show its ugly head again. The desired dose over what we have on hand times the volume. Now we can take our 800 micrograms, that's our desired dose, divided by 1600 micrograms. This is the dose that we calculated to have on hand. And essentially we can write in, and I'm going to write in 1 ml, just so you can see that the volume is actually taken into consideration here, but we don't need it. We only need it because we're going to end up with a number of mLs here, and that's going to be per minute. So let's get rid of our micrograms, and we're going to say that this equals 0.5 mLs per minute. All right, that's all fine and good. Now we need to know how this translates to the number of drops per minute. So we're going to again convert using 0.5 mLs per minute. And remember, since we are giving a drug here and we need to be very accurate and precise with our drug administration, we're going to use a 60 drops per ml administration set. And in doing so, here we're going to say that 60 drops for every 1 ml. We'll get rid of our milliliters, and that'll leave us with the number of drops per minute. All right, so if we do this calculation, it'll be 30 drops per minute. Now, if we want to figure out how many drops per second this is, then we'll just conclude that by doing 30 drops per minute times 1 minute divided by 60 seconds. We can get rid of our minutes. We're left with drops per second. Drops per second. And if we do this calculation, 30 divided by 60 gives us a half a drop per second. So 0.5 drops per second is kind of a random number. We could also say 1 drop every 2 seconds. That's the same thing. So in essence here, we're going to give 0.5 drops per second, but that's not realistic. We can't even begin to calculate that. So we're going to actually say we're going to do 1 drop every 2 seconds. So this is one way of calculating dopamine drips. The way that we calculated this drip is we started off with a couple things that we knew. We were given the amount of drug that we had to give per kilogram per unit of time. We calculated, but we were really given the total concentration of the drug based on that 400 and 250. We were given the patient's body weight in pounds. We converted that into kilos. We then calculated the total number of micrograms that we had to administer per minute. We then figured out how much volume per minute that translated into. Then we converted that into the number of drops per minute, so that volume is then converted to drops. And then we wanted to figure out how many drops per second. And so we're going to give 1 drop every other second, every 2 seconds. So this is one way of calculating that. Now, I'm going to show you a different way of calculating that also. So let's take a look at that in the next video. So stand by.